So I'm going to present my investigation on the Hrudaya Kamalam Rangoli and the mathematical patterns found in it. Yeah, you can go to the next slide. So Rangoli is a traditional art form made using dots and lines. So many Rangolis, they contain mathematical patterns, sequences, and symmetry. For this project, I explored the Hrudaya Kamalam Rangoli, as you can see in the picture, which has 8 sides. And then I investigated how the number of dots changes as the Rangoli grows and about its symmetry. Next slide. To investigate this, I focused on 5 questions, which were how does the number of dots increase at each stage? Is the increase always the same? What type of pattern is formed? How does the symmetry appear in the Rangoli? And does the design remain balanced as it grows? And my research question was how does the number of dots change when the Rangoli grows? And what patterns and symmetry can be observed? Yeah, next slide. So as you can see in the pictures, stage 1 has the pattern of 1 and 2. And stage 2 has the pattern of 1, 3, 2. It's the pattern of how we draw the Rangoli and not the dots. It's how we draw the Rangoli. And then stage 3 is a pattern of 1, 3, 2, 4. And stage 4 is a pattern of 1, 3, 5, 2, 4, which is the actual Hrudaya Kamalam Rangoli. These patterns, one thing is the odd numbers come first and then the even numbers. So the odd numbers increase first and then the even numbers increase. Yeah. Next slide. So this is the increase in data. I mean the increase in dots. As you can see, stage 1 has 5 dots. How many? I'm explaining the number of dots in one side. So as you can see, stage 1 has 5 dots in the vertical side, and stage 2 has 7 dots, um, and stage 3 has 9 dots, and stage 4 has 11 dots. So when I compared the stages, I found that the number of dots increased by 2 each time. You can go to the next slide. So the pattern I found is like the number of dots follows the sequence 5, 7, 9, 11. So this is a regular arithmetic pattern because the difference between the consecutive numbers is always 2. So this forms a regular arithmetic pattern, as I said. And the rule is the next number of dots is a previous number of dots plus 2. So if the pattern continues from stage 4, the next stage would have 13 dots. Yeah. So in the 5 and 9 dot patterns, uh, the observation I made is each rotation begins from a new starting point. So if you start at one dot, you have to end at that dot, and then you have to go to the next dot which is available. So as you can see, I think stage 1 would be more understandable. We have to go to the next dot which is available and start there and end there. This applies for stage 1 and 3. Yeah, the slide is there. So, ma'am, can you go to the slide with parent? Yeah, the rule to find the number of dots which have a new rotation is 4n plus 1. And in the 7 and dot and 11 dot patterns, the design continues around without needing a new starting point. It starts and it never stops until the whole pattern finishes. As you can see, it starts in one place and it goes on and goes on. So yeah. And one question for you guys is like, can you find if the numbers 21, 13, and 56 and 39 need a new starting point rotation? Can you find it?
Maybe you can ask just only one.
Okay.
There are so many
Do you
numbers.
think 21 needs a new starting point or it does not need?
Okay, maybe they can think and come back. You can.
Okay. So, okay, another question I have is Avan, could you yeah, another question I have is I want to ask everyone how much sides of symmetry do you think, lines of symmetry do you think the Rangoli has? Like leave the stage 1, stage 2, stage 3 and stage 4, how many symmetry do you think it has? Anyone?
Anyone want to answer? Like, how many lines of symmetry? Do you think there is a line of symmetry, or if so, how many lines of symmetry? Okay.
Okay,
Is it
okay.
four?
Is it
Uh,
four? Mm.
4. Okay, that's a thing. But I also got deceived by this same thing. I also thought it was 4 or 8, but it is actually not. So the Rangoli, it has a symmetrical dot arrangement. If you can see, I have put the dot arrangement of the stage 1 and stage 4. That's a symmetrical dot arrangement, but the overall design is not symmetrical because the pattern does not remain the same when it is viewed from different sides, as there is a different like uh, pattern we are doing 1 2 1 3 5 2 4 1 2, so it does not remain symmetrical, and this is only true for stages 2 3 and 4. In contrast, stage 1 Rangoli has a symmetrical pattern. If you can see one, it has the small one. And for the rotational symmetry, stage 2 and 3 have a rotational symmetry order of 1, while the stage 1 Rangoli has a rotational symmetry order of 8. Yeah, next. So uh, this, yeah, it is actually like a video. You can actually see the symmetry, but I do not know how to come in. Yeah, you can see the
I think
symmetry.
it's not. Yeah.
Yeah, you can go to the next slide. There's a video again. So yeah. So my conclusion is that the total number of dots follows the sequence 5 7 9 11, increasing by 2 at each stage to form a regular arithmetic pattern. And it both all the stages maintain a eightfold symmetrical dot arrangement, but dot arrangement is only symmetrical, but the design is not actually symmetrical, except stage 1, which has a eightfold rotationally symmetrical design, and others have uh, say order of 1 rotational symmetry. So yeah, thank you. You can move.
Okay. Yeah. So that's a good presentation, Meera, on how you see some mathematical patterns in the Rangoli and how do you connect the symmetry also.